I got to stop drinking so much cough syrup.
It's looking so good, I'm going to start. Welcome to the Hackaday podcast. I'm Elliot Williams.
And I'm Al Williams.
This is episode 224. We'll be talking Star Wars holograms, tricorders, and other sensors. This week in the news, good/interesting news coming out of the EU. It looks like a move to get all sorts of batteries in portable devices to be removable has passed through the parliament, and this may have impact on cell phones. You may be able to get cell phones with replaceable batteries again. I have to say, this very week took my old cell phone, bought a new replacement battery for $10. It was delivered the next day. And it's like a brand new cell phone. It's delicious. So come join me.
I got to admit, Elliot, I've done the cell phone battery swap a few times, and maybe it's just my lack of skill, but the phone's never the same after that, right? I mean, as far as just the fit of the case, I usually have something that just doesn't feel right. It's hard to put your finger on it. So I'm hoping they'll actually do this. And I always think it's funny with the batteries. You know, the what was it? The Radio Industry Association or whatever way back said, hey, we got to have standard battery sizes. And that's where you get, A batteries, AA batteries, AAA batteries, and the AAAA batteries that Tom talked about the other day, and the C and the D and all those lettered battery sizes. So can you imagine if every thing that you had to say, well, I'm going to go to the store and get the GE batteries to fit my GE appliance, and I need some Panasonic batteries. But that's kind of the situation you're in with the cell phone. There is some commonality, but not enough to where you can just say, here's a cell phone battery. So hopefully this will start to clear that up maybe a little bit. We'll see.
And it's not just cell phones, of course, it's all portable electronics. And so like last week in Hackaday, we had a couple articles about harvesting the lithium polymer batteries out of disposable vapes. And in principle, that would mean those have to be made easier to take out and replace. Like it's a really weird world that we will inhabit if all sorts of portable electronic devices have replaceable batteries. I don't know.
I can't imagine what they're going to do with the earbuds, like an AirPod, right? You almost couldn't make those replaceable.
Oh, that's going to be a tough one.
I guess you could, but it seems really hard, right?
Yeah, they're going to have to make some, small press fit case with a rubber seal or something. That's going to be tough on them. It's Apple. They'll figure it out. It just seems, it seems horrible to throw away the multiple $100 headphones because the batteries don't recharge anymore after 3 years though, right? Then we have two Hackaday contests in the news this week. One is we just announced the winners of the Op Amp challenge, and you can go check it out. We're recording on Wednesday night, and I just published this post. By Friday when you're listening, it'll be old news. But if you haven't seen it, do go check it out. This is another one. We had like 83 entries, and a good 50 of them are worth looking at.
I was really impressed with the analog computer. I've always had a urge to go play with analog computers, which were kind of going out of vogue when I was a kid.
Right.
But, that seemed like that was one of the more interesting ones to me. But you're right, there was plenty to look at. The one with the LED wave array just for optics, that was really cool.
That one's cool because it also, each one of those little panels is completely independent of the other ones. And, it takes input on one side in terms of the voltage and propagates the wave along. But the whole thing is, of course, done with, analog electronics. So it's the wave equation in analog, and it's like literally voltages being passed across these 4x4 array boards, and they're all plugged into each other. It's a phenomenal build as well as being a really conceptually cool piece.
Well, and I also like the homemade op amp. I thought that was cool. That's a classic thing to have to go simulate, is the long tail pair transistors and the differential amplifier. And, I've always been really interested in odd uses of amplifiers like that. If you go dig into instrumentation, there's all these tricks they use, like, a chopper, or having this, what is the switch capacitors, where you switch the capacitors in and out to get the noise to be common mode. And, we don't see a lot of that anymore because usually you just buy some chip and it's the function, but it's great to see that people still have that expertise and will apply it. So
Yeah, and there were a whole bunch of kind of obvious synthesizer, musical instrument, amplifier, mixer kind of projects in here, any of which are cool if you're into that sort of thing, and not a single one of them made the final cut for the big prize at the end, but all of them are really cool in and of their own right. And looking through the judges' results on this one, I had the feeling that there's just so much cool stuff remaining that we should highlight for y'all.
All-in-one gamma ray spectrometer. How can you not go look at that one, right?
Yeah, right?
Ball and box simulator with real gravity. That's a good one.
That one's actually really good.
Yeah, so that's just a glance at the first page. So,
and if analog's not your style, you're more futuristic-y. We had such a great time with the Cyberdeck challenge last year. We're running it again this year. So 1 year has elapsed. It's time to do Cyberdeck again. So we have just started that up on Tuesday, and it goes until August 15th. So if you're interested in playing around with quirky portable computers, it's futuristic Cyberdeck time again.
This is a journey into sound.
What's that sound?
What's that sound?
Well, then, from more challenges to more challenges, let's head over to the What's That Sound? Last week was a Guess the Sound week. That means this week's going to be a drawing, but it would be unfair to not give you a chance, Al, to have a listen to this one and guess what it is. I have to say, you're a shoo-in for this one.
uh-oh.
Oh, yeah.
No pressure, right?
No pressure. Dan Maloney hammered it.
All right, let's see here. Oh. Well, I'd say that's a Star Trek tricorder.
That would be correct. Can you name the show?
Oh, that's a good one. I think it's got to be Next Generation, maybe.
Absolutely right. Let's see. I can't ask any more fine-grained questions. That's all I got.
Was it before or after the change in producers? Yeah, there you go. That's
Exactly. No, you're going to know more about this one than I do. So Dan got this too. He's like, it's a tricorder. I'm like, yeah. He's like, maybe TNG. And I'm like, yes.
yeah.
Damn it, you guys. It's just such an awesome sound. It's got like a modem-y kind of sound overlaid over the warbly sound. And like the old Star Trek, it's just the warbly sound. And then the newer ones, they make it even more complicated. So this is kind of this in-between zone.
I actually almost blurted out it was FSK right at the, because that first quarter second sounds FSK. But luckily I held my tongue. So, all the Star Trek noises, even on the old show, they were mostly pretty realistic, except for like a lot of times the computer, they say, Mr. Spock, get us a computer readout on that. And you'd hear something that sounded like a paper tape punch, boom, 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 boom. And you think, well, that didn't wear very well, but at least they did have the 3.5-inch floppies. They just didn't know what they were. So, but a lot of other shows didn't do that nearly as well. Like Star Wars, if you listen to some of the old original Star Wars sound effects, there's clearly CHU, the Canadian time station, in the background, right? That bleep, bleep, bleep. It's
really
very obvious CHU, yes.
How cool. All right, well, let's pick a winner here. We have 30 correct answers, which is close enough to a binary number that I'm going to flip a coin. And I've actually got a piezo disc. So we're going ceramic side is heads and solid metal side is tails. So ceramic side is a 1. So here we go. First of 5 flips is tails. So that's a 0 for the 16s. Oh, a 0 for the 8s. Uh-oh. Am I ever going to get it? Yes. There's a 1 for the 4s. A 1 for the 2s. So we're at 6. And a 0. So number 6 is Nick. Congratulations. I'll get in touch with you and get you a t-shirt. Awesome names this week include Matthew to Beam Up, Optimistic Red Shirt, Mind the Tribbles, and Guy Who's Attended a Wedding performed by William Shatner. So let's get on to talking about hacks. I have 3 fantastic ones this week. They're all like in-depth and nerdy, like I like them. First off, a volumetric display with a Star Wars look and feel is a 2-video series by Maker's Mac where he makes a volumetric display. This is a display that gets a 3D effect by moving the surface that it's projected on up and down in sync with projecting different layers of it. So it actually, your persistence of vision then kind of puts them all together and you can see the different layers of this 3D image, physically represented in space. Really cool. It's an old trick, but this is a totally new take on it. He does it by taking apart a DLP projector, and normally they do DLP projectors in full color by rotating a color wheel across them, and to get a high frame rate on there, the DSP, cripes. The advantage of using a DLP projector is that they normally have a very high frame rate because they have a color wheel that goes in front of the multi-pixel mirror. And so it'll shine out what pixels need to be red and then what need to be blue and what need to be green. So it essentially already runs at 3 times normal frame rate. And he needs a high frame rate here because he's trying to get your eyes to do persistence of vision as the projected surface moves up and down. Really cool idea. He runs into a bunch of problems along the way, ends up using the shutter from 3D shutter glasses to make the individual layers line up. He has a voice coil from an old speaker that moves the projection screen up and down, but it didn't have enough travel, so he ends up with this fantastic living hinge mechanism, compliant mechanism design to make it work. There's a bunch of electronics in here to get the timing right. This is just an incredible build that takes apart some, DLP projectors are pretty high tech, and then repurposes the whole thing to make this awesome volumetric projection surface movie thing. And then, of course, has to slice up models from Star Wars to get them floating in space like a hologram. Really, really cool looking project, and you will learn a lot if you follow along with it.
I'm just so enthralled with the fact that 3D printing has enabled this entirely different class of projects, right?
Right?
I wrote years ago before there was a Hackaday, I wrote somewhere how I really wanted a 3D printer because they were very expensive at the time. Because just like I couldn't write, say, a book on a typewriter, but I could write it on a word processor, I can't go into a machine shop and build all this stuff that you can get the 3D printer to spit out. And I think this project really captures that because there's a lot of the 3D printed pieces, right? Like you said, with the living hinge and all that. The DLP stuff, you were mentioning about the wheel. I had a DLP TV for years, and one of the things that's odd about that, there's certain people, and I'm one of them, that if you're looking at the screen and then you look away, you can see an after image of the color wheel.
Oh, yeah.
And some people can't see that, and I don't know I'm sure there's some gene or some biological reason for that. But that also works looking at the hubcaps of cars in motion. Like if you're driving down the road and a car is driving next to you, look at their hubcap. Don't do it while you're driving. Be a passenger. Look at the hubcap, look away. And I think if you're the person who sees the DLP color wheel, you'll also see like a freeze frame of the hubcap going down the road. And then some people don't see that. So I've always been interested in that from a persistence of vision point of view.
Man, talk about the 3D printing here, though, too. This is something that Mac had never done before. Like he says in the video, I didn't know anything about these compliant mechanisms at all before I started. So I just looked it up online and started modeling stuff, and I tried this and I tried that, and he makes it work. This is a very impressive build, but it's also absolutely a hack from beginning to end. And then he wraps it up in this like fantastically begreebled Star Wars looking case. So that's pretty sweet too. There's something for everyone here.
Well, my first hack for the week is actually the cosmic ray navigation, which came out of a paper from some Japanese researchers. And really, cosmic rays, a little bit of a misnomer. It's really muons that are generated by cosmic rays hitting the atmosphere. And the thing about these muons is that they penetrate deep into the ground and deep underwater, and of course through buildings and everything else. So if you've ever tried to use GPS in a building, forget it. And if you try to use it in a garage or a cave or even underwater, it's very unlikely that it's going to work. And that's what this is trying to solve. If you look at GPS, you've got the satellites beaming out a signal. Well, it turns out there's about 10,000 muons reaching every square meter of the Earth every minute of the day. So there's plenty of these muons hitting the Earth. So if you set up some reference receivers, they will be able to say, oh, look, there's a little burst of muons. And then when you see it, you can compare it to where the other 4 reference receivers saw it. And just like GPS, you can figure out where you are relative to the reference receivers. Obviously, you need to know where the reference receivers are. And on top of that, you've got to have some way to communicate with them. So with the GPS satellites, you're listening to a radio signal. Here, that would defeat the purpose because the radio signal isn't going to penetrate the, 400 meters underground or whatever. So you've got to have some kind of network or some arrangement to where they're talking. But it was super accurate, and the paper is really an interesting read. I don't know if the technology's actually ready for prime time yet, but I think there's a lot of cases, especially where you've got robots navigating inside, say, a warehouse or anything like that, where having that kind of precise positioning is really, really important. One of the most interesting things about this, which is kind of a red herring, though, when I was reading about the muons, they have relatively short lifespans. So you wonder how they can go so far into the Earth. And apparently that's one of the ways you can show that time dilation actually happens is in the muons time frame reference, it's a very short lifespan, a couple of hundred milliseconds, I think, if I recall correctly. But they're moving at 99% the speed of light. So in our frame of reference, it takes, a good long time for them to decay. And that's what allows them to get hundreds of meters under the ground before they fizz out. And they do fizz out. They're not like neutrinos where they just shoot through the Earth and keep going. So I thought it was very interesting. I don't know that it's not that hard to detect muons. I mean, we've had muon detectors before. So conceivably, somebody could cobble up a system like this and experiment with it tomorrow.
I guess the thing that is different between GPS, and you hinted on this, is that you have to then talk back to the detectors. And that's what's so stunningly awesome about GPS to me is that it's entirely one-way communication, right? You just sit there passively receiving from these satellites. And, because they have well-synchronized clocks and because you know where they are in space, because of the almanac and the ephemeris and blah, 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 you can actually figure out where you are. Whereas here, I think they can't encode their time into the muons.
If I understand it correctly, their system may have had two-way communication, but I don't think you'd absolutely have to have that. So, let's say we're doing mining and we're crawling around with a robot in a cave. Maybe it's sufficient that the robot can hear us from antennas inside the cave, even though maybe the robot doesn't have enough power to beam back. So I think as long as you could broadcast the data, you would have to say, I saw this burst and it was at this time. And you obviously would have to discipline the clocks. For GPS, that clock discipline happens because the satellites encode their time information. So I think that would be feasible to do.
Yeah.
But I wouldn't swear to that. I don't want to be, I'm not under oath, but I think you could do that.
Yeah, if the surface detectors were able to tell you when they saw it, then okay, I buy it. Well, speaking of triangulation or something, this next hack, using sonar to measure traffic speeds, is a sweet project by G-Dub. He has a street with a 30-mile-an-hour speed limit, and he wants to see how fast the cars are going down the street, and he wants to do it using sonar. What's interesting here is he started off thinking, I could use Doppler and try to figure out how the pitch changes as the cars go by, and he actually did try it, and what happened is that the pitch didn't change. Why? Because most of the noise coming off of the cars driving down his street was road noise. And the road isn't moving relative to you at all. And this is what I love about the difference between theory and practice, is like, my first thought was Doppler, and then the answer is no, road noise. So he ends up using 2 microphones in a kind of simple array to figure out where the car is and locate it in space. So he uses the relative arrival time of the noise at one microphone versus the other to figure out the angle to the car, and because he knows they're driving on the street, he can tell where it is. So he's got this great deep dive into doing the correlations here, into how he builds the microphones. All the hard math is done with GNU Radio, which makes kind of doing this sort of convolution by fast Fourier transform multiplication and then unfast Fourier transforming it very, very simple, and it's actually, all kind of plugins. He filters it beforehand. He ends up with this really beautiful looking waterfall plot where you get these like squiggly S's that correspond both to the time delay between the two different microphones and kind of the car's position in space. Using the slope of these, he can figure out how fast the cars are going. Totally anticlimactic. He lets it run for 71 hours, gets like 9,000 cars, and the average speed is kind of 35 miles an hour on a 30-mile-an-hour street. So I mean, I guess that's good, right? It proves that his model's probably working just about right because people are speeding just a little bit, which is kind of what my prior would have been anyway.
My old algebra teacher used to say you have to take what you know and use it to find out what you don't know. And I find that little phrase covers all my sensor experience in my entire career, right? So I think this is a case of that. What can you do? Well, I can listen to the cars. I agree. That was such a great build, and the beautiful math and the waterfall display.
Presumably, for something like that, you'd be using a very large number of microphones, wouldn't you?
So I was surprised, too, because like you say, Doppler seemed to be the thing that would make the most sense. And then, of course, you could have done RF radar, you could have done LiDAR, could have tracked the Bluetooth MAC IDs. There's so many different ways you could do that. I wonder if you could even do a computer vision system and just say, well, it was this size, and then 2 seconds later it was this size, so I can calculate the differential. I don't know. There seems like there's a lot of different ways. Maybe that's a Hackaday contest, right? How to determine the speed of a moving car the most absurd way possible.
I think the computer vision way is actually the straightforward and obvious way. Part of it, I think, is, though, that he's constrained. He lives in a house that's fairly far back off the street, and the street runs parallel to it. He's doing this actually in his window. So if you think about it, the baseline between the two microphones is actually only the width of a window. So it's kind of, a little bit bigger than shoulder width apart. So it's amazing that he gets as much resolution as he does on these. I don't know, it's just such a sweet analysis. And if you scroll down to the very end, there's kind of limitations, discoveries, and thoughts about what to do next. And they include, you can't do it with more than one lane going in the same direction because the noises overlap, but you can actually do it if they're going in opposite directions because you can tell one car's going from left to right and the other's going from right to left. So that's kind of cool. But, this wouldn't work for like 5-lane traffic or something. Some things are moving too slow, like people just don't show up. They kind of fall out of the fast Fourier transform. He has direct line of sight on the street, so there's no problems with reflections, but you can see that there are some kind of unintended reflection-y things in his signal, but he's still got a clear enough peak that it doesn't bother him. When it rains, you can't hear it. If there was snow everywhere, you wouldn't be able to hear it. There's just all sorts of fun thoughts and discussions on using this method. Man, the cost of doing this is just a Raspberry Pi, 2 microphones. I guess he was using a USB sound card, and so just plugging the microphones into the left channel, the right channel. Boom, you're done. It's a simple build. It's a sweet bit of work, and just an awesome project.
And a cool use of GNU radio, I might add. So
yeah, I love those uses of GNU radio that are outside of the radio world.
Well, a number of years ago, we did some posts on GNU radio, and I think that's how we started, was doing audio processing first, right? Because that lets you not have to worry about all the radio end of it. And then we eventually graduated to the radio end, but probably should look that up and throw it in the links.
Absolutely. I mean, it's like a DSP toolkit.
Well, my next hack of the week was one I actually wrote up from Retrobytes, where they had a video about the history of ArcNet. And I had actually run into ArcNet many years ago, but I was surprised at how many comments came in on this particular post with people with recollections of those days. And in fact, someone sent us on the tip line a copy of the ArcNet newsletter from 1998 that had a history of it. And I got to go figure out if there's somewhere that lives on the web we can throw a link into it, or if we've got permission to put it somewhere. ArcNet was, a very common network before Ethernet was just basically rolled over most things. IBM had Token Ring. Data Point was the ArcNet folks. And Ethernet had its set of proponents like Xerox and people like that. When the IEEE opened up for standards, someone in the comments said that they actually had approached DataPoint and said, do you want to be considered for the standards? And they came back and said no. So what a terrible story, right? In retrospect, you think, oh, wow, that was probably not the right thing to do. But ArcNet had a lot of proponents. It was a lot easier to wire at that time. It had a longer range, had kind of a star architecture, which was easier to manage. And you might think, well, gee, that's not hard. Ethernet's not hard to do that. But I think the trick is Ethernet today is not hard to do that with. In the old days, you had a large piece of coax and you had to put the transceivers at wavelength marks on the coax. The coax would come with little marks on it at a quarter wavelength, and you were supposed to put the taps there. And then another cable ran down to your Ethernet card from that transceiver. So it was a lot of wiring. It was a lot of work. It was thick cables. And because it was sort of a round robin kind of affair, it was very difficult to make very long networks because it wasn't everything going from a central location. It was just a ring, basically, and there was some very strict limits on how big that ring could be. The other trick ArcNet had up its sleeve that was fun was that you could reserve some of the bandwidth on that coax for video conferencing. And so they had very advanced video conferencing in those days compared to, what we had now. So you have to wonder if ArcNet had prevailed and presumably gotten better, just like Ethernet got better and better. Would we have had the Zoom meeting 10 years earlier than we did? I don't know. It's kind of interesting to contemplate. But there's a lot of that old technology that just kind of big deal in the day and then just vanishes and now hardly anyone remembers it.
You're telling me that Ethernet used to be not on twisted pairs?
Yes, it was a big innovation when it went from the thick Ethernet to the thin Ethernet, right?
That's
the
why
RG
it's thin Ethernet.
It was RG8 and then it went to RG58 and we were all very excited about that because it was easier to run RG58 than the big RG8. I think I got those numbers right. I'm sure someone will write in to correct me if I'm misremembering, but
yeah, because I've seen those old token ring networks and stuff, but I don't think I've ever seen ArcNet in the flesh. Huh.
It's still in use, apparently, in a few minor cases, but it was quite popular for a long time. There were several times I considered deploying ArcNet, and miraculously enough, deployed Ethernet back when that wasn't the obvious choice, and turned out to be a good choice in the end, but that wasn't always clear.
Cool. My last hack this week, how to land a model rocket vertically. This is a sweet video description of a tremendous success by TTS Aerospace. We've seen a lot of people in the model rocket community doing thrust vectoring on the rockets, active thrust vectoring. So if the thing starts to lean over to one side, you tilt the nozzle over and compensate for it. One of the things that lets you do is try to run the thing in reverse and land it again. And this is really neat. He's got 2 solid rocket cartridges in it. The first one fires, it goes up in the air. It fires the second one when it's on its way back down and uses the thrust vectoring to land, flips out its legs, bam. And, he shows one video where he absolutely sticks it. And then, of course, all the other videos where he's been working on it for the past 4 years. This is not a simple problem. But it's really, really cool that there's a kind of community of amateur hobby rocket people working on the same problem. I mean, this is what was kind of really cool about the SpaceX rockets. And here you have individual people, probably TTS Aerospace, he's probably in college and he's doing this. It's really, really cool to see his progress. And he says he made it as simple as possible. But that means, of course, he designed his own onboard computer. It's got an accelerometer. It's got a pressure sensor. It's got, the board has the facility to fire off the 2 rockets and flip up a parachute and do a whole bunch of other things, actually. It's a pretty complex package. And then, of course, there's the software layer on top of this that has to figure out how to get this thing safely to the ground. And it's got all of the common culprits. It's got PID loops. It's got methods to sense when the rocket is at apogee, when it's at the highest point in its flight, because it has to know that to figure out when to fire the landing rockets before it hits the ground. So there's a whole bunch of really interesting problems to be solved here. And, he gets it done. Really impressive. as simple as possible is quite complex here, but I do believe him that it's as simple as it possibly could be and have it land on its rocket motor.
Well, as a science fiction buff, that's certainly the 50s aesthetic was the rocket, just big flames coming out of the back of the rocket and it lands and, Gort comes out or whatever. That's awesome. I agree with you. I mean, this is one of those things that would have been bone crushingly difficult to do earlier than this. And I think it's still pretty difficult to do. If you really have spent any time working with rockets, they're pretty unforgiving and it's much harder than people think. So the idea of saying, well, I can, make an LED blink with an Arduino, I think I'll go build a man's rocket is really a bad thing, right? Kudos to this guy. This is something that even big companies don't always get right, as we've seen, and took a lot of work with, and he's basically rolled it himself. So it's very impressive.
There's a whole ton of details here, like, for instance, how he uses rubber bands and overbent carbon fiber tubes to make the legs come down. He experiments with the damping because this thing hits its landing legs and, needs to land on them and not keep bouncing around. And he experiments with a whole bunch of dampening systems there. Ends up actually just leaving a little extra slack where one of the carbon fiber rods fits in the little shoe. When I think about it, it's hard enough for this little rocket to figure out how high it is up in the air when it starts to fall back down. And he's got an accelerometer, he's got a pressure sensor, but if you don't know what your elevation is over the ground, it makes it significantly harder to do the calculation to tell when to turn the rockets back on. Plus, when it starts to fall, it's actually keeled over by kind of 30 degrees or 45 degrees. So when he starts the rocket engine back up, it's not pointed straight down like you would want it to be. It's pointed off to the side, which means A, the rocket's going to go off to the side a little bit, but B, you have less thrust in the downward direction than you think you do until it gets straightened out. And so there's all sorts of competing little bits of error that could end up, that at least to my mind could end up with this thing thinking it has a few more feet above the ground than it does and just, going through the zero axis. I don't know. He pulled it off and it looks really impressive. There's a ton of simulation done here to figure out the timings and figure out when to turn the rockets on. And, lots and lots of Simulink. He says it drives his computer down to 0 frames per second.
I have enough trouble doing Lunar Lander on my HP 41C, so I think this is beyond my skill set.
Oh.
My last one for the week is from Horn and Road. It's the HueForge system, which allows you to print these very artistic 3D prints. And apparently what they were trying to do was come up with a system to do color lithophanes. And what they've wound up with is more of a model for how to lay down thin layers of filament and get different color effects. So if you looked at these just at a glance, you'd think it was some sort of handmade artwork or something you might buy in a marketplace at some tourist destination. And instead, they're 3D printed and very impressive. So the trick is you've got the filament at the very thin heights is not totally opaque. So you're able to layer down different colors of filament in very thin layers, I think 80 microns. And then the resulting colors are predicted by this model, and they're able to figure that out. So it sounds complicated, and I'm sure it really is, but one of the things you can do is just go over to printables.com and grab some pre-sliced models. And they even have them set up where you just manually change the filament if you don't have a better way to do that. And I haven't tried it myself, but man, just looking at the pictures, it looks like it would bring a whole new artistic bent to your 3D printing.
Their images are unreal. They have this one that Donald Papp, who wrote this up, linked in the article of 2 blue jay feathers they printed. You have to zoom way in to tell that they're 3D printed. And it's really just because they get the color shading effects right. All of their models look unreal. They look no longer 3D printed because they're doing this color blending so well. And they are using some kind of a multi-filament head, so they can change from one color to the next. But man, I've never seen anything like this.
Well, and they do say that it's the because you can see through all the layers, that they do minimize the number of filament changes. So I think at least for some of them, it's possible to do even if you've just got a single extruder. But truly amazing. And I do think it's interesting. They're still looking for the right sounding name for it. And I think there were a lot of comments that suggested names that I thought was pretty interesting. So maybe that's there's your next contest. Name this process, right?
The pictures, they're all so good. Like it's
amazing.
Really,
yeah.
I give up. Just when you thought you've seen everything.
Just when you thought your 3D prints were adequate, right? Now you can feel ashamed of your 3D printing again, just like
yeah, right. I got my corners square. That's good enough for me. All right, my first quick hack this week: bringing back the Minitel by Cécile Adam and Pascal Moise. This is basically a Wi-Fi card and a DIN socket to reconnect the old school French modem-based terminal units to something modern. Apparently, both Cécile and Pascal had worked on original development of the Minitel, so this is kind of a trip down memory lane for them. And what's interesting is that they're also planning a bunch of web-based services that you'll be able to connect to. So you'll be able to reuse your old Minitel if you happen to be in France and trawling around eBay right now, buy one, to explore this new content coming up soon. Next up, Hackaday Prize 2023 entry, Sleek Macro Pad makes two-factor authentication a little easier. This is the 2FA sidecar by Matt Perkins. It's got a little OLED display on it that shows a number of two-factor rolling codes, and then it's got 4 or 5 buttons. So you press one of the buttons, it spoofs a keyboard, it types the numbers into your computer for you for all those times you have to enter two-factor codes into your web browser. I love this as a standalone hardware device. And last up, SJM4306. The Remote Duino Nano is a tiny IR remote that's truly universal. Yeah, it's a universal remote control written in Arduino. It's not much wider than, 4 LED widths. It's got a couple buttons on it, also has an IR photodiode on it, so it will be able to learn new codes in the future that way. IR remote control is such an easy, accessible technology and it's just so much fun to play with. I love this kind of simple, kind of inviting hack.
Okay, my quick hacks for the week. Daniel Ross, who we've seen before, has a steampunk tachyoscope. The tachyoscope apparently was a real device, but of course a real one didn't have LEDs and Arduinos in them, or I think actually just Atmels, but I don't know if they were Arduinos. But it matches up with his steampunk 1802 computer, which actually looks like something behind the curtain in a Wizard of Oz movie from the 1930s, right? It's all very Victorian looking, really cool. And so one of the things that's interesting, we've seen a lot of POV stuff, of course, but this one has 2 serial ports and 2 separate POV displays in different colors. So you can actually feed 2 different data sources to it and it will show both of them or show one or show the other. He had a very interesting slip ring because obviously you've got to have some way to get the power and data over to the rotating part. And it was a Rube Goldberg. I mean, he cut apart D-cell batteries and took apart a VCR for the bearings, and I forget what all else, but it was wild. And that brings me to the next quick hack, which was Big Clive has an eBay slip ring with 6 circuits going, I think three or 6 circuits going through it, and took it apart and showed what was inside of it. So honestly, it's a good contrast. If you look at the Daniel Ross tachyoscope, you can see how to build your own slip ring, and then you can go look at the next one and see how to buy a slip ring, and you'll probably decide that's a little easier. My third quick hack was from Nino Ivanov, and it's the punched cards are in the cloud with this Arduino. I don't know, it just struck me as fun. It was very small punched cards that get read by an Arduino, and if you haven't read the post, the amazing part is what's on the punched cards is a program written in Lisp. So he's got Lisp programs punched out on cards. And I don't know, I think it reminded me of the old build your own digital computer book from the 70s or 80s, where, the core memory was paper clips and the switches were thread bobbins. Well, they had their program drum was an oatmeal drum with a paper program wrapped around it and aluminum foil under that. And it would read the program, you'd cut out the part that was your instructions. And so it just kind of reminded me of that, had kind of a nostalgic feel to it, and I thought it was a cool project.
Quick hacks.
All right, that brings us to our Can't Miss articles. These are long-form pieces written by our fantastic Hackaday writing staff. This week I'm picking Tom Nardi's review of the Infraray P2 Pro thermal camera. Why? I guess I have thermal camera jealousy. This one's a really cool one. It has an up-close lens on it as well, so you can do the kind of standard, image the side of your house and see which window is leaking sort of application. But much more of interest to electronics hobbyists like us is that it's also got a macro lens on it, so you can focus really close up and figure out which resistor is getting hot. This is one of a new wave of thermal cameras coming out of China that all have the same kind of medium resolution sensor. I guess it depends on what's medium. It's a low resolution compared to a camera, but it's high resolution for a thermal sensor, 256 by 192. This new crop of sensors has been domestically produced in China, and so they're tremendously cheap. And I think there are a number of these on the market. They refresh pretty fast. I think in the future, we're going to be seeing a lot more of these, and we're going to be seeing the price dropping even further. And I think that's super interesting. This one, it's nothing much more than the sensor. You plug it in by USB-C with a little extension cable into a computer or a cell phone. Tom does complain about the software on it. That, I guess, is no surprise. But you can do your own image processing on it if you get the data out. And some people in the comments linked some libraries to use the infrared sensors in raw mode. And so you can then do your own data acquisition and processing. So you're not actually held hostage by the crappy software, which I think is pretty cool. 25 frames per second, that's not bad, and pretty decent resolution. Tom has a great demo of him pulsing a resistor, and you can watch it heating up and cooling down. And he points out you can actually see the traces sucking the heat away from the resistor as it cools down and they heat up. So really, really cool. I have one of those super low resolution 8x8 ones, and I've actually found that even by itself useful. I guess I've played around with some FLIR cameras and stuff. They're pretty cool too. This one is what, $300? So yeah, it's not super cheap yet. I think I'm going to wait till it gets down to the $150 range till I personally buy one. But that said, I don't have a real use for it. I would just be having fun with it.
Yeah, I also have IR camera envy because I have nothing. So I keep looking at these and, like you say, the resolution seems off-putting and it's still better than some of them you see at that price range. So I'm sure it's one of those things where if you actually need it, it's fine, but it doesn't sound real good. And then the big differentiator does seem to be the software. And I don't know enough about it to make a pick, so I have not moved on it. I think as far as watching the heat signatures of resistors and things, it always reminds me of an old project. I can't believe I've never seen anybody do it lately because I think it'd be a lot easier to do. But years ago, I had the pleasure of working on a research project where we would shoot high-energy electrons at an IC die and watch the secondary electron emissions off of them. And that way you could tell if the conductor you were aiming at was, charged positive or charged negative based on the energy of the secondary electron emission. And so with a lot of image processing, which in those days was a computer the size of 2 large refrigerators, and now would be, a third of your cell phone.
Yeah, right.
You could actually sit there and scan the electron beam across the die, thousands of samples, as long as you were in the very same conditions all through that scan, and build up an image of the IC, where the positive was light up and the negative was black, or vice versa. And then if you moved that in time a little bit, you could do things like watch data in a loop running through the bus, and see it actually propagate down the bus. And this was all very high speed ecologic and of course, just getting the electron beam is still a problem, but that would be cool to see some hobby applications of that. So it makes you wonder, where are the other ways to scan like a PC board? I don't even know if secondary electron emissions is the right answer for a PC board, but do we need a scanning IR scanner? Does that maybe give you higher resolution with some of these cheap things? Or I don't know. It just seems like there's a wide open field for some experimentation here that we're just not seeing yet.
having a macro lens on it definitely opens up a lot of other things. Like, it's not quite like you were describing. I don't think it's quite the microscope that you want to be on one chip with, but getting pretty close there. That's interesting.
Well, and we did have another review of a different IR camera, and that was one of the differences is it didn't have a macro lens. So if you look at Voltlog's review, that was one of the things he was saying, well, it's not that useful for the kind of things you normally want the camera for because it doesn't have the macro lens. Although he did find it useful. The macro lens was a important part of making it useful.
And I guess Tom closes out his review by saying usually he tears this sort of thing apart, but he actually wants to use this thing and keep it intact. And he's pretty sure that there are no user serviceable parts inside. But he does link out to a video by Mike's Electric Stuff where he takes apart the exact same model. So if you've got your teardown needs unfulfilled, you can head on over to Mike's Electric Stuff. I do think we'll be seeing a lot more of these in the future. I think Infraray actually may be the company that makes the sensors in question, but we've seen them rebranded in a whole bunch of other devices. And, this is what happens when you have kind of native Chinese production of it, is that everybody's going to be getting those sensors and putting them in devices. Anyway, really cool. Expect to see a flood of cheap infrared cameras on the market soon.
Okay, my can't miss for the week is Dan Maloney's Radio Apocalypse, Hardening AM Radio Against Disasters. So we've been talking a couple of weeks in the Hackaday bunker about the car makers wanting to remove AM radio. And, there's the usual arguments. Well, AM radio's kind of devolved into the least common denominator radio programming. But it turns out AM radio is fairly critical for a lot of disaster planning. And we've talked a little bit about disaster planning, especially in the United States before with things like Conelrad. But I think it's interesting. We do the series Tech in Plain Sight. This is almost a Tech in Plain Sight in that there's all these people, probably all over the world, but particularly in the United States, that are sitting here thinking about what happens when this bad thing happens, right? What happens when, you get bombed or you get disease wipes out half the planet or whatever, and they make plans for it. And maybe those plans are good, maybe those plans are bad, but a lot of those plans involve AM radio. Kind of like we talked about the rockets, where you think it's easy until you go approach it, or the audio tracking of cars, you think, oh, that's easy. And then when you go to do it, you find out there's a lot to it. Part of the planning of that is like, well, we want people to be able to hear the radio, but we don't want enemy bombers to home in on AM radio stations and use them for navigation. So they rotate the AM radio stations in certain schemes and things like that. So I just thought it was very interesting that there's all this going on, and that even an old technology like AM still has use in that, and they just changing it or getting rid of it has all these unintended consequences you wouldn't think of. On a selfish note, I really hate to see AM radio go away, because I still think that's a great thing for a kid to do, is build a crystal radio or a really simple radio in 5 minutes that actually picks up anything. And I think if AM dies, that's going to become much harder to do. It's already pretty hard to do for a couple of reasons, but going to get even harder. And I think it's just more barrier of entry for the kids. Of course, nobody's going to keep AM radio around just for that reason, but I still think it's a good reason.
Well, if they give us some bandwidth, we could broadcast on AM just for, just to see, right?
So can I be Radio Hackaday's first DJ?
Absolutely. As far as I'm concerned, yes. And as far as the FCC is concerned, as long as you're in a truck, I think you'll be fine. Just keep moving around. They'll never get you, man. The single diode AM radio receiver, the crystal radio or whatever is super cool. And I think that is part of the reason why a little bit of AM still makes sense. I mean, this is talking about disaster events, and if there is some sort of horrible disaster that destroys a whole bunch of things, what could you recreate? You could probably recreate a crystal radio if you absolutely needed to, right? Like without batteries, without anything. I guess the tricky part's getting those super high impedance earpieces.
Well, look at all the prison radios that were made, especially the POWs.
Yeah.
And of course, like you say, there's a lot of things that aren't available anymore. It used to be a phone receiver was a perfect speaker for that. You could use a razor blade and a pencil lead for a bad detector if you absolutely had to. But honestly, I don't know. I guess I still have a few straight razors, but they're not everywhere like they could be. Just as a side note, though, one of the things I thought was really entertaining about this article is it shows you how it has changed being a journalist of any kind anymore. Because Dan has in there the picture of the FEMA upgrades for WWL, which is the clear station channel in New Orleans. And you can see he's just got it off Google Earth, right? I'm thinking there was a time when we would have had to give Dan a plane ticket so he could go, or, at least a photographer, if not Dan, to go out there and get that picture. Or more likely, we just wouldn't have had the picture. But now you just kind of sit at your desk and you can get a picture of anywhere in the world in a few minutes. So pretty cool.
Okay, that wraps it up for this week's Hackaday podcast. Thanks very much for listening. If you'd like to follow along with the links, head on over to hackaday.com/podcast. And if you see anything cool or do anything cool, send us an email, tips@hackaday.com. And until next week,
Keep those hacks coming.
bonsai. Why am I saying DSP? What are they called? DLP. DLP.
I think we're done with that one, yeah.
Mm-hmm.
Something like that would take an unusually large number of microphones.
I don't think I have anything else to say.
Well, let me start that over.
Everything censors these days anyway.
That way you cover Star Wars and Star Trek.
Well, I'm done.